Hi all, I'm Swati and I'll be the moderator for this room, Emerging Areas in Innovation. We have Nandan Chhabra presenting accessibility and mixed reality. This will be a pre-recorded video. However, Nandan will be joining us for Q&A later. Thank you.
Hi, good morning, everyone. Thank you so much for having me here today. My name is Nandan Chhabra. I'll be sharing my views on this topic accessibility and mixed reality. This is a lesser known topic and not very well explored due to its emerging nature, and I personally have been very passionate about this from past several years. To give you a small introduction about myself, I'm working with Nagarro as a QA automation lead, and I have almost 8 years of experience. I try to keep myself updated with the latest technology and I give hypotheses around the upcoming one. Before we proceed further with this presentation, a quick couple of notes. I'll be sharing a couple of videos and graphics to help us all understand the different concepts mentioned here more distinctly and in simple language. I hope these play well for you. Now let's see at this excerpt from Gartner Top Strategic Predictions for 2020 and beyond. Through 2023, 30% of IT organizations will extend BYOD, that is bring your own device policies, with bring your own enhancement, that is BYOE, to address augmented humans in the workforce. So let's understand what this means. During this pandemic, we have seen how companies all around the globe, from various sectors such as automotive, retail, advertisement, medical field, e-learning, etc., are making use of these connected ecosystems, or we can say augmented technologies to enhance human capabilities to what we call as human version 2.0 and increase the overall productivity of the person. One such area where we are yet to focus on is how accessible these technologies stand in the current scenario. This is what we'll be discussing in our subsequent slides. So I personally encountered, or you can say, got enticed about augmented reality during my college days when I saw this movie. Let's play this movie or clip.
Jarvis, you there?
At your service, sir.
Gauge heads-up display.
Check.
Four-door preferences from home interface.
Will do, sir.
All right, what do you say?
I have indeed been uploaded, sir. We're online and ready.
Jarvis.
So this is a scene from this movie Iron Man. More than visual effects used in this scene at that time, it was more about how this and where this technology is heading. Given my lethargic nature, this view gave me an insight of how we can use this technology in different areas and do stuff without losing our comfort zone. Going forward, couple of years and coming back to our today's topic, as the name suggests, we will be discussing about what is accessibility and what is mixed reality and why are we discussing about these two together. Then we will discuss about some of the challenges people with special abilities have faced using this technology and what all mitigations we are there to overcome those challenges. Then we will briefly discuss how we can test these new upcoming technologies. So let's start with understanding what is mixed reality. I think it is right to assume that everyone here has in some way used these filters in applications like Instagram, Snapchat, or Facebook, etc. You can very well distinguish a couple of features of this application, namely how the goggles are being tracked and rendered on my face in real time, and how the face movement gesture is recognized with the application, and based on that gesture, we can see different shades appear. I think this is a very best example and very relatable example of augmented reality. This augmented or mixed reality domain is not just confined to augmented reality, it carries forward with it different variations of other types of realities, which will be pretty important for us to understand before going forward. For this, we need to understand the concept of reality virtuality continuum introduced by Professor Paul Milligram. So this is a continuous scale ranging between completely virtual to a completely real world, and whatever comes in between these two extremes is mixed reality. I guess we are all familiar with the virtual reality. Since these 360 degree videos and PlayStation VR, all these things are pretty common these days. Virtual environment is basically a computer-generated environment with almost no essence to real world. Let's dive into more details around the realities of our interest. This middle area is subdivided into two sections, that is augmented reality and augmented virtuality. If you can see from this graphic itself, you can see that this particular robot is augmented inside a physical world in augmented reality. On the other hand, these real world objects are placed inside a augmented virtual world. Briefly, we can say that in augmented virtuality, a real person or a real object is augmented inside a virtual world. However, in augmented reality, a virtual object is augmented inside a real world. Let's see this another image that gives you a better picture of how this transition looks. We can see that there is more of reality in the real world and there is less of reality in the virtual world. Now let's understand this bit better via this small video from the Weather Channel and how they utilized augmented virtuality to enhance our understanding of what all can go wrong during this snowstorm. So I'll just play this video.
I mean, just look at these power lines. All right, those icicles must be. Oh, gee! You got to be kidding me! Where did that come from? That giant icicle just fell from his cell tower. These ice missiles can reach speeds of 90 miles an hour and land with 1,000 pounds of force.
I'll just pause this video for now and let's see what is happening here. This person is standing inside a virtual scene which is created inside Unreal Engine. This is a gaming engine used for creating realistic looking computer generated scenes. Keeping up with the same theme, let's now see an example of how augmented reality feels different from augmented virtuality via this video, again from the Weather Channel.
If you're driving, whether it's back and forth to work or doing errands or just enjoying the fall color, you know, weather is always a factor. So we're going to look at why in the fall it's especially tricky, and that's because of the leaves. Let's take this car and bring it out into reality or augmented reality and talk about how the weather plays a role in your driving. If you're
I hope this has given a little clarity on both these topics. Going forward from here, let's take a deep dive into the world of augmented reality and understand the basics from there. So there can be mainly two types of AR applications out there, which can be categorized as one that does not require any markers and the other that requires markers for tracking purpose. We'll first talk about markerless tracking. As the name suggests, we don't use any special markers on the plane. Instead, we either use computer vision techniques to understand the three-dimensional real world around us. And once we are done identifying a plane, we drop that digital object that will respect real world boundaries. Second technique used to map the three-dimensional world is by using a special hardware, or we can say sensor, such as a LiDAR. Don't get confused by this fancy name. The concept of LiDAR is something similar that what we already might have heard about. That is radar and sonar, where radar uses radio frequency, sonar uses sound, and LiDAR over here uses lasers to map the world around them. This LiDAR system is now integrated in a couple of self-driving cars to map the real world in real time. And this has also been integrated in the new Apple iPad and iPhone Pro models, which certainly pushes Apple's game forward in this regard. Let's see an example of how markerless AR. You can try this at home if your phone supports AR Kit or AR Core. Let's play this small video. I'll pause this video now. You can see that in this example how this 3D object correctly recognizes different surfaces and how it occludes the 3D object behind the table by using the edge detection algorithm. We'll talk about occlusion again in the later slides. The next type is marker-based augmented reality applications. These uses marker or anything that is uniquely identifiable, just like your QR codes. In this next example, I'll show how easy it is to create a marker-based application. For this demo, I used a well-known gaming engine named Unity, and a plugin from Vuforia. This was previously owned by Qualcomm, now it's sold to some other company. So Unity provides us with the ability to interact and place 3D objects in 3D dimensional world, whereas Vuforia help us with the image detection and tracking capabilities, by analyzing the target image for unique feature points that can be tracked via the camera. So this is how the Unity interface looks like. This is our target image. I'll just move the video a couple of seconds forward. So this is the 3D model that I'll be using to augment on my target image. And I have also used a small rotating script that whenever I hover my camera on the target image, that 3D object that we used is rotate. So this is a small script. And this is what Vuforia sees and correspondingly extracts the features of the target image. And whenever it sees the same target image again, it matches the pre-saved values and augments our object on that. You can see it also rates the target image. We got a 5-star rating since it has so many features. So one learning from here is that more the features, better the image recognition and hence better tracking. So once that is done, we can export the package on our Android phone, open the camera, and this is what we got to see when we hover our phone on the target image. You can see that it's easily tracking the target image, and using our script, we are rotating the 3D model in front of it. And now next up is mixed reality. We kept this for the last as the fundamentals are already covered. This is a mix of virtual reality and augmented reality, and to help us understand this better, let us see at this small clip that how we can transition from our one reality to other. So this is a small clip using which was made using ARKit, and it's from inside a small office, and we have a virtual door or augmented door inside this office space. This person with the camera will walk through this door, virtual door. Right now it is augmented reality. And once it walks it down, we get to see the virtual reality part. That virtual reality part is basically a 360-degree video that you can see. Once he looks back, he can still see that virtual augmented door. And this is how these realities or the mixed reality will work in future applications. Moving on, let's discuss another important piece, that is human-computer interaction. You might wonder, why do we need to talk about this? But if you really give it a thought, using technology is all about how easy and how intuitive it felt while you were using it. And that is how you choose to use it, that particular piece of technology again and again. So human-computer interaction is a discipline that studies how people interact with technology, and also to study how to design systems that involve people and technology. It is very important to understand that when we talk about mixed reality, it can be in any digital form. We will talk about this later in the slides. To understand this better, let's take a look at this case study. So this is the analog thermostat, not readily used in India. However, this was used to control the room temperature in colder areas. So this design is a very intuitive one, as it gave a very subtle tick-tick feedback, or you can say mechanical haptic feedback, so that you could also use this with your eyes closed. Next comes the digital age, where we try to attach screens in each and every device possible. Here, the design flaw was the use of up and down buttons, which were intuitive VS, but didn't suit it well for this use case. Now comes a smart thermostat. So the main changes were the use of circular dial, like the one we saw on the analog thermostat. But here, instead of the mechanical tick-tick, we added a haptic engine. This case study helps us highlight how subtle changes to design of a product enhances its usability. Now let's talk about accessibility. By definition, it means the quality of being easy to obtain or use. And we consider that while we are talking about accessibility, we all should understand that it doesn't mean that we make a product more accessible to each individual, but specifically to specially abled person. As we can see in this image, specially abled people can be categorized as visually impaired. That means they have difficulty in seeing or have no vision at all. Hearing impaired means that they can hear partially or are fully deaf. Mobility impaired means they are either fully paralyzed or partially paralyzed. Or cognitively impaired means they have trouble understanding, learning, or recollecting things from their memory. Now the question comes, why do we care about this and what is the problem statement? So for this, let's look at this excerpt from Gartner article that talks about the top strategic predictions of 2020. This is the same article that we referenced before. So let's understand the brief highlights of these points. According to Gartner, by 2023, the number of differently abled people employed will triple due to the AI and emerging technologies, reducing barriers to access. And with the continuous development in these areas such as AI, AR, and VR, some emerging technologies will make work more accessible for specially abled people. Let's also get our facts checked from this demographic from WHO, published in the year 2011. Based on this, more than 1 billion people in the world have some form of disability. That corresponds to 15% of the world's population. I would say that's a huge market that we are not capturing as of now. Now we can say that what is stopping specially abled people to use these mixed reality or assistive devices? You might have noticed that whatever we discussed so far while understanding these technologies, they were more or less in the form of augmented visual information. The thing we lack here is that there are more ways in which digital information can be perceived. Say, for example, apart from visual, it can be auditory or in the form of vibration or haptic feedback or in the form of sign language. We know about the classifications of different types of disabilities. Each of the disability has their own unique limitations in the world of mixed reality. So let's discuss each one of them in brief. The most obstructing disability is visual impairment, in which a person is not able to do his or her daily tasks independently. Content developed right now seems very heavily visual, and usually for web accessibility, a visually impaired person is dependent on screen readers, which is as of now not compatible with these platforms. For the same reason, there are no proper guidelines to add alternate text and metadata for objects added in these platforms. Now let's look at how this can be mitigated. We can include the use of haptic feedback as an alternate means of providing information to users. Web3D Consortium are trying to develop open standards such as X3D, which can be integrated with HTML. Mozilla's WebXR and W3 are trying to incorporate accessibility standards as the awareness about this issue is rising. Sensory substitution devices, SSDs, can be used to aid virtual mobility. SSDs use visual to auditory conversion, where whatever camera sees, it converts it into high and low pitch sound so that the specially abled person can understand what is in front of him. Now let's look at this application from Microsoft. This is only available on iPhones as of now. So what it does is it uses machine learning and artificial intelligence to identify what is in front of the camera and converts it to audio for visually impaired. This is just one example as of now that we can showcase. Let us now see what challenges a hearing impaired person faces. Here the challenge is that we can see the visual stuff but cannot hear the audio cues being presented in the immersive environment. Sign language is not supported as of now. Due to Bluetooth latency issues, a partially deaf person might face challenge to access this technology. And it is tough for them to interact using voice, as usually it happens that if you are not able to hear anything, it is difficult to communicate using the voice as well. Now let's see what all mitigations we have for the hearing impaired person. We can start adding audio instructions in the form of live captions. Haptic feedback can also be used in this case as well. And support for sign language to communicate will be a plus. In this image, we can see how verbal dialogue is converted to real-time captions on the deaf person's screen to help them communicate. And here's a small idea that how we can incorporate sign language in immersive world using these 3D models. Moving on. People with motor disability often are unable to use devices that require precise controls or move their head around, and also might not be able to comprehend the haptic cues from the devices such as haptic feedback sensors. This technology often provides an escape to motor impaired people from their current condition. So more input devices options should be made available. Audio inputs or the use of voice assistants can be used to control these devices. We can see in this graphic that how voice commands can be used to make things happen around us. And here is a small video of a fully paralyzed man enjoying skiing using virtual reality. Now let's look at the challenges what cognitive impaired people faces. So this area needs some special treatment as this comprises of special people with specific requirements while using these head-mounted devices. User interface might be too complex to learn. Virtual world skills may be difficult to acquire for these people. Input devices such as controllers, etc., might be difficult to master as they might feel difficult to handle these devices. Users may suffer from motion sickness, and fast moving objects or flashing lights may cause seizures or migraine. So, the mixed reality market should focus more on content management for these people, as this tool has been proven useful in treatment of problems like anxiety disorders and pain distractions. Let's take a quick look at this case study. This elderly is suffering from dementia and Parkinson's disease. Dementia is a very common disorder amongst people older than 60 years. They usually face problems like memory loss, difficulty in communication, and hallucinations. Whereas Parkinson's, a person's central nervous systems get affected, leading to problems like shaking, difficulty in walking, etc. So in this case study, this person is suffering from both these disorders. Somehow, he was able to walk freely without support when some horizontal lines were laid on the ground, as we can see here. So to mitigate that, augmented reality came to the rescue and added these horizontal lines virtually on the ground with this head-mounted display. Now let's take a deep dive into what the testing arena and see how we can test these applications. Now let's look at the testing snapshot. Simulate end user. As a tester, it will be at most important to understand the requirement and then test an application from end user's perspective, as the requirements might differ drastically from user to user. Latency issues are most common in such applications where multiple components interact with each other, such as audio, visual, head tracking, and sensors in the device, etc. These devices are often reasons for motion sickness in some people. We need to ensure that the environment presented is not too overwhelming for the user. Occlusion, as already discussed, needs to be tested, which is a property where the digital artifact understands the boundaries in the real world and crops itself to ensure a seamless digital experience, as you can see in this graphic image. In head-mounted displays, it is important to check that first, the device correctly registers the user motion, and second, the application responds to the motion in a natural way. For testing sound, there can be two cases. One is a specialized sound that gives you a feeling that the sound is originating from a single point of source and remains locked to that location. And the other is head-locked sound that follows your head movement. And definitely we need to check this for different screen sizes with different screen refresh rates. These are things that are commonly tested for. Now let's see what all challenges one might face while testing these AR/VR applications. Well, this area is still under research, so everything is constantly changing and evolving. This technology as of now is not robust to changes and hence might not work properly every time. AR application doesn't work well on reflected surfaces. As you can see on this image, my face is the target image as of now, and I've augmented 3D models on my image. And when there's reflection on my face, it is not able to track my face correctly. Scope of these are limited as because of the availability and stability being the main causes. These are meant to be tested in open environment, hence testing might not be very comprehensive. It has relatively high dependency on onboard sensors, leading to other issues like battery drain and heating issues. As these things are still changing rapidly, no accepted standards are available right now. And last but not the least, no major automation tools are available as of now. So before we open for questions, I would like to say that we are making sure the websites these days are more accessible. We need to start exploring this area as well and start grooming ourselves so that we are ready for these challenges going forward. Now I'm open for the questions. Thank you so much. Yeah, hi guys. You can share any questions that you might have. There was an interesting reason that I recorded this video. The reason basically was I don't want latency issues while showing the videos that I wanted to show. And given this context, we are in a pandemic, and I think we all have evolved eventually and rapidly in this pandemic. We have seen multiple companies ramping up their skill sets and ramping up how we have seen the Zoom issues that were faced. Reason being there were very privacy concerns, so they made a beta product, but which is not uh, secure in a platform that it was meant to. But they eventually went on for that. So virtual meetings and all these areas are rapidly growing in this pandemic situation, and the problem here is just that awareness about this issue. And given the challenges that we personally face while accessing some new technology, it's something different. Well, when we discuss about people who are specially abled and are not basically able to access this technology, no one thoughts about this. And this is an area where we as testers needs to gear up and understand these challenges and raise this in a right platform so that the developers, as they are still bringing up these technologies up to space and making POCs, they can understand and make sure that correct things are or correct changes are deployed when the time comes to for the specially able people to join the force. I'm yet to see any questions as of now. And there's another instructing fact that I wanted to share that uh, in Russia this year, I think the cows were they were facing issues with the anxiety, so they use virtual head-mounted displays to soothe the cows and make sure that they are able to eat properly in that area. So I think, yeah. So the awareness basically is very important first. So you can try explore these applications that are out there because they are basically working very well. Not completely perfectly, but they are doing it very well because AI is involved, machine learning is involved. So the face tracking is very accurate these days. You can see filters from Snapchat and Instagram. So they accurately map your faces correctly so that a mesh can be made out of on your face, and you can make any changes in the face itself. So I think one area is covered, the face mapping or face mesh mapping. And apart from that, I think other areas would be to detect the surfaces with less patterns, or you have some objects that are kept there so that you can map the environment around. So recently Google also updated their algorithm for surface detection in their AR core library. So I think people are working. We need to raise the right questions and make sure that these things are heard about. I think we don't have any questions yet, so I think that will be it from my side. Thank you so much for having me.